Hey there, statisticians. This is the beginning of Chapter 6, when we're at that distribution and see how we can calculate probabilities of events happening. What I want to focus on, first of all, is that experiments and observations are how we get data. And when we get that data, we can analyze it and process it and look at the probabilities of something happening. For instance, the example here might be counting the number of eggs in a nest, or measuring something as rainfall. Well, what we do to quantify these things, or we call it a variable, right? And that's x. So the number of eggs in a nest, x. Well, how many did we count? The first sample we had 3. The second sample we had 4. The fourth sample we had 0, right? X is a variable. It takes on many forms, and it's the thing we're trying to count or measure. Well, when we talk about discrete and random variables, discrete variables take a finite number of forms. And you saw this, for example, when we surveyed the entire school. How many cars are in your household? Well, 0, 1, 2, 3, etc. It's a whole number. And discrete things are whole numbers of things. Continuous things could be values, such as weight. Well, how much do you weigh? Well, 134. Is it 134 whole or 134 and a half? How much rainfall? When you start saying how much, you're probably talking about continuous. When you're talking about discrete, you're saying how many with a specific number. And that's what this says in the yellow text. And that's important because really this chapter, we're going to be looking at discrete distributions when the outcome is either true or false. So let's dive into this for a second. When we talk about a probability distribution, we assign a probability to each distinct value that a variable can hold. And we've already done examples of this. We make columns and tables, and you're going to see it's quite familiar in just a second. What you have to remember is the sum of all the assigned probabilities must be 1, and the probability distribution is assigned to each distinct value of the random variable. And this is what it really looks like. So I've got a situation where Dr. Mendoza developed a test to measure boredom tolerance. And he gave it to 20,000 people between the ages of 25 and 35. So you could only get a score of 0, 1, 2, 3, 4, 5, or 6, which means it is clearly discrete. You can only take those values. And the idea of a 6 has a very high tolerance for boredom, meaning you can handle a very boring job. Someone who got a 0, good luck trying to get them to make lattes all day. So the question at hand here is, based on these 20,000 people, make a probability distribution, make a relative frequency histogram, that should sound familiar, and then a company, top-notch, wants someone with a 5 or a 6, so what's the probability of that? And then finally, we're going to find the mean and standard deviation. And that's really the whole nutshell of this first section. So let's go ahead and do this. I'm going to move myself out of the way. I'm going to drop a quick line over here. And this column here, and I'm going to go to the board and do this, and I'll really try to speak up so you can hear me. Here's your x's, right? It's the distinct values that can hold. The number of them is the frequency, right? Now what we're going to do is we're going to calculate the probability. So how do we do that? Well, if we know there's 20,000 people in our study, the probability of x will assign to each one. So the first one would be 1,400 divided by 20,000, right? And that's 7%. So this is 1,400 divided by 20,000, and we're going to do the same thing for each one, right? And that's 0.07. And we're going to do that all the way down. So next I'm going to do 2,600 divided by 20,000. Right, so we go through 0.13. Next one, 36. Right, 0.18. Now, of course, my writing's different. 6,000 divided by 20. 0.3. 4.4 divided by 20. 2, 16 again. Oh, no, I didn't have it yet. and 400. And when I add all these numbers up, this better add up to 1 or really darn close to it if I made a little rounding mistake. So again, 7 and 13 is 20. 20 and 18, 38. 38, 68, 70, 90, and 10 is 100, 1.0. Okay, so now I have actually made a probability distribution. First part's complete. I've determined the probability of each one. Excellent. Now, make a relative frequency histogram. Let me extend my page and show you what I'm talking about. So what that means here is I'm going to make, and you guys have been making histograms for a while. I'm going to make my lines here. That's bad. Try again. Right, and I go through, and I'm going to do, okay, we've got 0, 1, 2, 3, 4, 5, 6. Right, and then these are the percents, basically. It's the probabilities. So I've got 0, 1, 2, 3, 4, 5, and 6. And then I just have to put my bars here. Now my highest, again, my highest percentage is 30%. So I'm looking for a number divisible by 2. Let's take this up to 32. Half of which is 16. Right? And so then I go through and I say, all right, 7%. There's my halfway point. Here's my halfway point. I'm going to go a little bit under that. Right? And then the next one is 13, so I'm going to go up to about here. And then the next one is 18, so I'm going to go up even higher. And then the next one after that's 30%, so I'm going to go even higher. I'm almost at 32, I'm almost at the top. And again, this should be really symmetric. And then I go to 22, up there. And then the next one's 8, which is right there at that bar. And then the last one is 2, which is just like that. So again, you've done this many times, and I hope you can now see, oh, right, now I can apply that to a probability situation like that. So I've made a probability distribution. I've made a relative frequency histogram. Now, what's the probability of getting someone with a 5 or 6? If top-notch, I mean, they're randomly pulling people and hiring them, what's the chance of getting a 5 or 6? Well, I could add those probabilities together. So for this question here, what I'm doing is I'm adding together those. So this would be 0.08 plus 0.02, and there's 0.1, which is 10%. So if an applicant is selected at random, there's a 10% chance of getting someone who is either a 5 or a 6. Sweet. Now, how do you find the mean? And how do you find the standard deviation? Well, let me jump ahead real quick and show you something. On a discrete, where is it? Let me get out of here. On a discrete random variable, the mean is called the expected value, right? And the standard deviation is the risk. So this is what it really looks like. So the mean, mu, which is x bar or mu, means the sum of each x value times the probability of x. And you add them up. The standard deviation means to subtract the mean from each x value, square it, multiply by the probability, add all those up, and take the square root. And so that's what I'm going to walk you through right now. I'm actually going to do this example on the one we just did. Let me get my mug out of the way. So the next thing I need to do is I got to make another column here. And I've got my probabilities. And it's getting a little messy. Sorry about the mess. I apologize. So now we're going to do x times the probability of x. And so what I'm talking about is, I'm talking about 0.07 times 0. And that's going to be 0. I'm talking about 0.13 times 1. I'm talking about 0.18 times 2. I'm talking about 0.3 times 3. I'm talking about 0.22 times 4. I'm talking about 0.08 times 5. And I'm talking about 0.02 times 6. And so if I add all of those up, and I am going to use my calculator here because I'm not going to try to do that one, right? And again, I just want you to see where this is coming from, right? I've got 0.13 plus 0.36 plus 0.9 plus 0.88 plus 0.4 plus 0.12, and I get 2.79. And guess what? That's the expected value. And in a discrete probability, the expected value, or the mean, does not have to be one of the possible answers. Just like if every household has on average 2.3 children, no one can actually have 2.3 children, right? It's discrete. You either have 1 or 2 or 0 or whatever. Nobody has 2.3, but it is the average. It is the expected value. So what does this mean? The expected value mu, or x bar, however you really want to look at it, is 2.79. So, of course, you can do this on spreadsheets. You can do it everywhere. Now, I only have a few minutes left, so what I'm going to do is I'm going to pause the video. I'm going to put all this together in an organized fashion, and boom, surprise, come back and make the next column. Let me pause. Hey, welcome back. We'll see the magic here in a second. So, again, I've multiplied each x value by the probability, added them up, and I got 2.79. That's what you're looking at here as well. So what you can see is I've rearranged these columns. I got rid of the frequency and just kept the probability. I've multiplied x by the probability for each value of x and then added them up. So this is my mu, or my x bar. Now what I'm going to do is, again, you've kind of seen these formulas before. In order to find the standard deviation, you take the square root of x minus mu squared multiplied by the probability and add them up. And this is what I'm talking about. So I take each x value, 0, minus the mean, 2.79. Do that, I get negative 2.79. I square it, and then I get that answer and multiply it by the probability of getting a 0, and I get 5.45. And I do that for each one. So for a value of 1, I take 1 minus 2.79, hit enter on the calculator. Then hit square it, enter, then multiply it by the probability, which is 0.13, and you get 0.417. And you do that for each one of these x values, and when you're all done, you add them up, and that's what this sum of x minus mu squared times the probability of x is. So you add up this whole column. I got 2.006. To find the standard deviation, you square root it, and once you have your standard deviation, you have indeed answered your question. And that's what you were asked to do, find the mean and standard deviation. So this is an example of how to answer that problem. Again, you would expect that someone would score a 2.79 with a standard deviation of about 1.42, meaning that's how much it's going to deviate from the mean on average. And that's very important to know when we look at other distributions, and we'll talk about that more in class. The bell. I better get rolling here. I think I've already gone through that. In fact, that's it. You guys have a great day. Jump on this next worksheet and we can discuss it more another time.